Welcome back to our channel, ladies and gentlemen. Now, how do we determine the red area of this radical geometry problem? So if we transfer this problem into the whiteboard, we will have the red area is the area of the circle minus the area of the triangle. So since the two sides are equal, we can drop a perpendicular bisector in that manner. So if we label this diagram, we let this to be A, B, C, then since the side BC is equals to the side CA, meaning this length BA is divided into two equal parts, so 6 is going to be divided into 3 and 3. So if you let the perpendicular height to be H, then this angle at vertex A to be angle A, then we can use the sine rule. So if this is angle A, the opposite side is going to be denoted by small a. If this is angle B, the opposite side is going to be denoted by small b. If that is angle C, then the opposite side is small c. Now, if you use the sine rule, we have A over sine A to be equals to B over sine B to be equals to C over sine C to be equals to 2R. Now we can use any. So if you start, for instance, sine A, because this is a right angled triangle, sine A is going to be given by opposite over hypotenuse. So you can see the opposite is the height h. So the opposite is h over the hypotenuse is CA, which is 5. So we have sine A is h over 5. And how do you get h? If you take this right angle triangle here, if this side is 3, this is 5, then meaning h is 4 according to Pythagoras theorem. H is simply the square root of hypotenuse square, which is 5 squared, minus the other shorter side squared, which is 3 squared. Then you get it to be 4 because of the right angle triangle C, maybe if you let that point OCOA. So h is 4. So if h is 4, then it is a clear indication that sine A is h over 5 is 4 over 5. So if sine A is 4 over 5, then we now have A over sine A over sine A should be equals to 2R. So if you substitute the side A is 5, so that is 5 over sine A is 4 over 5 to be equals to 2R. So there you'll get 5 times 5 will be 25 over 4 to be equals to 2R. So if you divide both sides by 2, then you are supposed to get R. When you divide both sides by 2, you get R is 25 over 8. 2 goes with the 2. You remain 25. 2 times 4 is 8. So R is 25 over 8. Now, having found the radius to be 25 over 8, so how do we get the red area? Now, the red area is very simple. It is the area of the circle, which is pi r squared, minus the area of the triangle, which is a half base times height. So what is that? That is pi r is 25 over 8 squared, then minus a half base times height. So you can see the base is from B to A, which is 6. Then the height h we found to be 4. So what do we get to be the red? To be the red area, 25 squared, that is 625 pi over 64. 8 squared is 64. Then it is minus a half of 4 is 2 times 6, 12. So it means the red area of this radical geometry problem is 625 pi over 64 minus the area of the triangle. The red area is the area of the circle minus the area of the triangle. Ladies and gentlemen, that is the simplest trick to deal with that radical geometry problem. Thank you for watching and see you again in our next presentation.